Cool. So now we have a trigger, this works, and now all we want to do is go add component, SuperJump. The way I did that is I clicked on add component here, and I typed in SuperJump. You could also drag it in directly from your scripts folder. You could drag SuperJump over like that. Your call. So let's test this out and see how it goes. I'm actually going to edit my camera a bit. This is just quick, move it over, angle it down a little bit, get a good angle on the ball. Gonna add my camera follow script from before. If you don't have this, don't freak out. You can snag it from the Facebook page. Drag and rollerball, and now I can see what's going to happen. So if I press and I move forward, let's see how the jump works, and almost nothing happens. It's just going to do nothing. And yeah, that's unfortunate. It's not the best. It might even be going underneath it. It's a little bit tall, so we could drag it down a little bit. But what the real issue is, to my understanding, what we can do to check is we can go in here and type in a debug log to make sure we're actually getting in here. So we can go back to our code, and inside of the compare tag player, so we know it's a player, we can type in debug with a capital D .log, and we can just say hit player, something like that. Just something to let us know that it worked. So if we go back to Unity and test that out, let's make sure that works. So if you see on the console here, we actually get this little hit player. So console by default is put here. I actually don't really like this positioning. It's sort of awkward, and it ends up being much more useful if you have it somewhere else. So what you can do is you can click on console from the tab right here and just drag it over somewhere else. So I like to put it on the bottom of the inspector usually. That way I can just see it all the time. So now when I press play and we test something out, I can get, right when I hit it, it'll just be like, boom, hit player. I know it. It's really easy to see. That's what I prefer. If you've ever done that and you keep moving around your windows and you mess them up a lot for whatever reason, you can go up to the top right here. Oh my god. You can go up to the top right, click on layout, and you can go back to default. I personally use something like this. That's the layout that I prefer. But you guys can mess around with it. You can see that you can see the game and the scene view at the same time here. It's whatever. But to keep everything consistent, we'll stick with the default view. Okay, so we know that we're getting inside and we're adding this force, but it's not enough. It's not doing the job. So just to make sure that it's working, let's go and multiply this up direction by like maybe that many zeros. That sounds about right. Let's do that and see how that works. So we go back to this and test it out. Boom! Okay, there we go. It got launched in the air. For everyone who missed it, it happened pretty fast. Now as you move over onto the cube, it will launch you up in the air and you'll go flying, and it's great. So we know that the force is working. We were just initially applying way too little of it. There's a few ways to handle this. So, gosh, I keep messing up the directions. So the reason for this is twofold. First off, 1 unit of force is pretty small in general. Like, you usually want to add more than that. And also, when we type in add force, for anyone who remembers physics, don't worry, you're not required to know any physics, but quick review. Add force, so F equals mass times acceleration. So like mass times acceleration. Got a thought? The issue with acceleration is that when you add it, it doesn't instantly push something. It just makes something like start speeding up towards the speed. So that's not really what you want in most cases, actually, when you're doing stuff like this. Instead, you actually want something more along the lines of impulse. So impulse ends up being mass times velocity, I think. Mass times velocity. So that's great because now we know, and in both cases they had an m, they had a mass, so we can just like sort of ignore it. Everything has a mass in it. You can sort of like right now I'm sort of just going to glance over it, but the velocity part is important. So we're adding more velocity to it in this case. So is there, I mean, but we could try, we could go and look and we say RB dot add impulse, but like it's not there, it doesn't exist. Like, okay, like that's not very helpful. It actually does exist, but Unity just manages to hide it really nicely from you. So the way that you do it is after our force that we're adding, we can put a comma in, and you can see in that little tooltip that it gives me that there's a force mode, .mode that you can put in. So right after that, you just type in force mode, capitalized like that, and then you do dot impulse. And you can see there are actually a few other options. So you could just do straight velocity change, which I actually might do, because if we do straight velocity change, then that means we can just say, ignore that, we don't need the M anymore, that doesn't really matter. So we don't care how heavy the ball is, we just want to bounce it. So this is obviously a design decision. In this case, yeah, I don't really think it will matter all that much, to be honest. Velocity change might give you more consistent results so that you guarantee that your levels are always the same. So I might stick with velocity change on this one, actually. And to illustrate this, let's turn this down to like 10 maybe, something a little bit smaller, and show how much this will change things. So if we go back into Unity and press play, and we start scooting forward and see what it does, boom. Gives you just a nice little bounce. Perfect. You can sort of try to balance on top of it if you want. It's a little bit difficult, to be honest. We have our own jump that you probably know through rollerball, so if I do this, I actually jump much higher than the super jump right now, which is inconvenient because that sort of renders our super jump power up null and void. So let's fix that real quick. There's a few ways you could do this. You could either, so this is a design decision for all of you guys right now. So you could either keep the jumping that is inherent to the rollerball and let the player jump whenever they like, and then just make the super jump really, really powerful, so it's obviously better than the normal jump. Or we could just take out jumping from the ball so that they have to use the super jump if they're going to be doing this sort of stuff. Yeah, cool. So this works. We have a power-up. I was just going over how we could handle this. I'm going to go over to my rollerball, and I'm going to take the ball script and turn my jump power to 0. I don't really want to mess with jumping in my design decisions. I think it's going to complicate things a lot. So by keeping everything on the ground, probably be a lot easier. And then just using SuperJump to guarantee that I know where the player is going to jump. Cool. So this works out pretty well, but there is a decision here that's not the smartest necessarily. So right here, I just have this times 10 just sitting in the middle here, and that's great, but the issue is that every single super jump power I make has to push it up with 10 as the amount. But that's not awesome. Sometimes I want super jump power-ups to be a little more powerful. So to do this, we can, similar to last time, make a public variable to expose it to whoever is the designer. So maybe you were just programming out these components, and there's a designer who's utilizing them. We want to expose parameters for them to alter. So for this one, I'm going to say public. So this public means that it's going to be exposed within Unity. If I say private, it won't. So public, I'm going to do float. Float means that, I think I covered this last time, but float means that's a decimal number. So there's float, and then the other big one is int. So int is like 0, 1, 2, 3, 4. Float is like 1.2, 3.6, and everything in between, right? So float just gives our designers a little bit more flexibility. So float, and then let's just do jump power, something like that. And we can actually specify a default value that we want. So I'm going to say equals 15 for my default value. And after doing this, I can go down, and instead of typing 10, I can type in jump power. So if we go back and test this, anyway, I should probably go back. I'll wait until, let me know when you guys are finished. So the idea is that now we're taking this up arrow that we have right here, so the amount that we're boosting it, this is length 1, and we're saying instead boost it like all the way up there. And this is going to be length of jump power. Sweet. Everybody good with the code? Okay, cool. Let's hop over to Unity. So now if we click on our power up, you can see we have our jump power parameter. So if I press play and start moving over to it, see at 15 jump power. It almost boosts me over. I bounce off the wall a little bit so I can maybe angle a little better. But yeah, perfect. 15 is pretty good. If you're feeling a little bit crazy, you could, what you can do is you can actually click over to the scene view like that, and we can start editing things right here. So you can click on things in the scene view while you're playing. But I'm going to go with SuperJump, maybe switch over to like 30 or something like that. Switch back to the game view and see how high that is. It's a little bit strong, to say the least. You could probably beat the entire level with a jump power of 30, so maybe not the best. But if you guys remember, since I was in play mode, when I press play and get out of it, it's going to switch back to 15. So that's awesome. So all of your changes that are done in play mode are going to be wiped clean when you go back into non-play mode, which is great for testing, not great for level design. Big no-no. Don't do level design in play mode, okay? You'll be very sad and you'll lose everything.